Evaluate the integral. In this particular case, we're asked to evaluate a definite integral because I've got the endpoints 0 through 9. So once we take the antiderivative, we still have to evaluate the function at the 2 points. Okay, so first thing I'm going to take the antiderivative. I have got the square root, so I'm going to rewrite this to the 1/2 power. So I'm evaluating from 0 to 9 to x to the 1/2 dx. I'm using my basic power rule. So adding 1 to the exponent gives me x to the 3/2, and then I divide by 3/2. Again, when you divide by that fraction, think multiply by the reciprocal. So multiply by 2/3. Right? And so cleaning up my exponents now, I've got my coefficients. So I've got 4/3, x to the 3/2, and I have to evaluate from 0 to 9. Okay, so now I plug in a 9, crunch my numbers, plug in a 0, crunch my numbers, we subtract those. So we have 4/3, 9 to the 3/2, minus 4/3, 0 to the 3/2. 9 to the 3/2, I get 27, so I've got 4/3 times 27, minus 4/3 times 0, 0 to 3/2 is 0. So 4/3 times 27, 3 will go into 27 9 times, so I get 36, and 36 minus 0 is 36. So my answer is 36. Find the area between the graph of f of x equals 50 plus 3x squared and the x-axis over this interval. It's important to sketch a little graph with all of the area ones. Remember, a couple decisions we have to make with the area is, is it above or below the x-axis if you're given only one curve in the x-axis. If you got two curves, which one is above, which one is below? Also, do they trade places? Do I have to split it up? And then the graph also helps you see your endpoints. Okay, so I know this is going to be a parabola. My vertex is at 50. It opens up. So something like this. And like I said, I don't need it to be a perfect sketch, just an idea. And then my endpoints, we're told that it's going to be from -1 to 3. So from -1 to 3. So I'm looking at this area here. So below that curve, above the x-axis, between -1 and 3. Okay, so notice that the function f of x is above the x-axis. So that means I'm going to have, f minus 0. That's what I'm taking the antiderivative of. If it had been below the x-axis, I would have to use negative. Okay. So the definite integral I want to set up my area is going to be the definite integral from -1 to 3 of f of x. So 50 plus 3x squared. So my antiderivative, I have 50x. Add 1 to the exponent. Divide by my new exponent. Like I said, I'm going to simplify that. So I end up with 50x plus x to the 3rd, and then again we evaluate it from -1 to 3. Okay, so from here it's just plugging and chugging in your calculator. When I plug the 3 in, I'm going to have 50 times 3 plus 3 to the 3rd. And I think it's a good idea to just plug that into your calculator and get the number for that. So that turns out to be 177. And now I plug in a -1 everywhere. So 50 times a -1 plus a -1 to the 3rd. Again, if I plug that into my calculator, crunch the numbers, -51. Okay, so I have 177 minus a -51, so 177 plus 51 will give us 228. So the area bounded by the curve, the x-axis between -1 and 3 will be 228 square units. A population of bacteria grows at a rate of p prime of t equals 12e to the t, where t is time in hours. Determine how much the population increases during the first 3 hours. Okay, so what we're given the rate of population, and then we're asked to find how much the population increases during the first 3 hours. So this can be set up using a definite integral. Okay, so during the first 3 hours, that means t is going to be going from 0 to 3. So our change then is going to be the definite integral from 0 to 3. My rate is 12 e to the t. All right, so the antiderivative of e to the t is e to the t. So we get 12 e to the t, and then we have to evaluate from 0 to 3. So I plug in my 3, so I get 12 e to the 3, and then the 0, so 12 e to the 0. Let's see, so 12 e to the third power, I get 241.02, bunch of stuff. And then 12 e to the 0 is 12. So subtracting those, I end up with 229.026, and we're asked to round it off to 2 decimal places. So 229.03. And my label is going to be, bacteria, because I'm looking for how many bacteria, what the population growth is. Because of material shortages, it is increasingly expensive to produce 6.2 liter diesel engines. In fact, the sales in millions of dollars from producing X 100,000 engines is approximated by S of X, where X is between 0 and 20. For which values of X is the rate of sales decreasing? Okay, so on this one here, usually when we want to find out where a function is increasing or decreasing, we will look at the first derivative, do the plus and minus chart, see where it's negative and therefore decreasing. This one's got a little twist to it. Notice that, we are given, the function that we're given tells us the sales from producing X 100,000 engines. So this is my sales, but what I want to know is where is the rate of sales decreasing? So first I have to write my rate of sales function, then I can determine where it's increasing or decreasing. So rate of sales, I'm going to call that R of X, is equal to, how do you find the rate of sales given the sales? You take the derivative. So this being negative 3x squared plus 60x plus 10. Okay, and I know some students will say that's the first derivative. Yes, it's the first derivative, but it's also the rate function. Okay, so that's the function we want to work with. That's the one we want to find where it is increasing or where it is decreasing. Okay, so if I want to know where R of X is decreasing, I take its derivative, I do its plus and minus chart. So first derivative of my rate function, R prime of X, is equal to negative 6x plus 60. I'm going to factor out my negative 6. And so I can see that my critical number is going to be X equals 10. So I'll come over here. I will do a quick plus and minus chart for 10. One thing I want you to keep in mind, though, is we had a limited domain. We are restricting this between 0 and 20. So when I set this up, I'm going to cut it off between 0 and 20. Okay. So test point, I'm going to go ahead with 1. When I plug a 1 into my first derivative, R prime of X, I get negative 6 times a negative, so negative and negative is going to be positive, therefore it is increasing. Between 10 and 20, I'm going to go with 11. So get a negative 6, and then 11 minus 10 is positive 1. So positive and a negative is negative, so it'll be decreasing. Okay, so I can now see that it is decreasing on the interval from 10 to 20. The annual revenue and cost functions for a manufacturer of grandfather clocks are approximately R of X and C of X, where X denotes the number of clocks made. What is the maximum annual profit? Okay. So we're asked to find the maximum annual profit. So this is a max min problem. It means I'm going to, an optimization problem. I'm going to find my profit function, and then I'm going to do a plus and minus chart, figure out where I have a maximum value. So first I have to do is write my profit function. I'm given revenue and cost. So profit, remember, is equal to revenue minus cost. So for me, P of X is equal to my revenue function, 480x minus 0.03x squared minus, and then my cost function, 120x plus 100,000. Okay. Make sure you distribute your negative sign to the cost function. So I'm getting 480x minus 120x. I'm going to get 360x minus 0.03x squared, and then minus the 100,000. So that is my profit function. Right. So now I need to find out where it has a maximum. So get my critical numbers for my first derivative. So p prime of x is equal to 360 minus 0.06x. I will set this equal to 0 so I can get my critical numbers. So I get 360 minus 0.06x equals 0. If I bring my 0.03x over, so I get 360 is equal to 0.06x, and divide by my 0.06, and x is going to be equal to 6,000. Okay, now I have to verify that this is a maximum. So here's my 6,000. I know it's going to have to be, greater than 0 because x can't be a negative number. So picking a test point, let me go ahead and if I go with a 1, and again I'm plugging it in here to my profit function. So 360 minus 0.06 times 1, that's going to be positive, so I'm increasing. And then I pick a number like 7,000. So when I plug 7,000 in here, I get 360 minus, and then my 0.06 times my 7,000. So minus 420, that's going to be a negative, so it's decreasing. Okay, so I can see then that I do have a maximum at x equals 6,000. All right, so I come back up here and they ask me what is my maximum annual profit. Okay, so I know when it occurs. Now I need to know what my maximum profit is. So that means I have to plug it into the profit function. So what is P of 6,000? Again, plugging it into my profit function right here. Actually, I'm going to plug into my profit function right here, where once it's simplified. And I'm going to get $980,000. That's my max profit, and it occurs when 6,000 grandfather clocks are manufactured and sold. The total cost in dollars of producing X cell phones is approximated by the function c of x equals 2,000 minus 30x plus 0.2x squared. Find the minimum average cost. We're asked to find a minimum function value, so this is an optimization problem. Our first step is to figure out which function we're trying to optimize. We want to find the minimum average cost. So recall that the average cost, or c bar of x, is equal to the cost function divided by x. So in this case we have 2,000 minus 30x plus 0.2x squared all over x. So I need to go ahead and find the derivative. That's when I can get my critical numbers and find out where I have a max or min. When I go to take the derivative, I'm going to reduce this fraction first, or I could, you can go ahead and use the quotient rule, but I'm going to reduce it. So I have 2,000 x to the negative 1 minus 30 plus 0.2x. And so now when I take the derivative, I'm using my basic derivative rules. So negative 2,000 x to the negative 2 plus 0 plus 0.2. Now I will set this equal to 0 so I can find my critical numbers. So we have a negative 2,000 over x squared plus 0.2 equals 0. There's a couple different ways of solving this. You can multiply through by x squared to clear your fractions. Another way is I'm going to bring my fraction to the other side. So I have 0.2 equals, now it's positive, 2,000 over x squared. Then I can cross multiply. So 0.2x squared is equal to 2,000. Divide by the 0.2. So x squared is going to be equal to, I get 10,000. And so x is equal to plus or minus 100. And since we're, x is going to be the number of phones, we know that x is going to have to be plus 100. Okay, so that's my only critical number. Now I got to decide or determine that it is indeed a minimum. So if I use my first derivative test, there's 100, 0. I'm going to go ahead and choose 1. And again, I'm plugging in my derivative here to test it. So if I use the 1, negative 2,000 times 1 to the negative 2, that's negative 2,000 plus 0.2, that's a negative. It's decreasing. And then something greater than 100, if I go with 200, I go ahead and I plug that in for my x. And then negative 2,000 divided by 200 squared plus the 0.2, that's going to be positive. And it's increasing. So therefore I have a minimum at x equals 100. Okay. So now I have to go back, reread the question, make sure that I answer it. So if I'm asked to find, how many cell phones or the demand, I've got that x is 100. I was asked to find the minimum average cost. So now I need to go ahead and plug it into my, cost function. So I need to find C bar of 100. So plugging this into my calculator, and again, I'm using my average cost function. I get, let's see, 1,000 over 100. So I get 10. So the average cost will be $10 per cell phone.